Hello, my name is Charanjit Singh. I am from India. I have done civil engineering from back home, and I also completed 1 year course from Conestoga College, and my course name was Construction Techniques. But now, currently, I am studying in Fleming College, and my course name is Project Management. And today I'm going to discuss my class assignment on hisarna, which is developing sustainable steel production process. As we already know, steel is the most recycled industrial material in the world, and it is produced through highly energy intensive methods. So hisarna result shows that we can make a significant contribution to improving the sustainability of the steel productions with this the Tata steel technology. Hisarna technology would prove to be a game changer in the steel industry and pave the way for sustainable steel production globally, and also offer many solutions to the challenges like increasing pollution, growing carbon dioxide and greenhouse gases emissions, and climate change. So this process can be the game changer of the industry for the Tata. Tata Company was founded in 1868 as a trading company and had operations in more than 100 countries by 218. The group had featured on the list of world's most reputable and most innovative companies for several years. Tata Sons Private Limited is the holding company of Tata Group. 67% of equity capital of Tata Sons was held by Philippine trusts. Tata Group always strived towards doing the business in a sustainable manner. In the mid 2000s, the group introduced a policy to ensure its carbon footprint. The group was active in climate advocacy and also measured water footprint since 2012. In 2014, a new organization, the Tata Sustainability Group, was formed, which partnered with other Tata companies in their CSR initiatives. Tata Steel was incorporated in 1907 in India as Tata Iron and Steel Limited and can commence its blast furnace operation in 1999. In 1918, it established India's first steel plant. In 1984, it introduced basic oxygen furnace steel making, where liquid steel was produced in 45 minutes. It then went on to introduce new technologies like hot strip mill, cold rolling mill, etc. As per the strengths, it lowers the operating cost of steel making, and it has also reduced 20% of CO2 emissions, and it also increased 20% more energy efficient and 25% less CO2 intensive, and it has also reduced 80% in the carbon footprint, and also 60 to 80% reduction in other emissions like dust, NOx, SOx, CO. And there is also an increased flexibility of raw material usage. And the weakness of this process is like that it relies on the carbon based fuel, eventually high emissions, systematic defenses like and also financial problem like partnering plus cost, efforts, risk. And this process is also like some kind of time consuming and also highly payback period. The further step is opportunity. The process work and is stable, and the testing and the further development of this technology is being carried out in collaboration with other companies, and the next step is to commercialize the technology, and the Tata Steel is considering building a large test plant in India. Moving to the last analysis, it is a threat, and there are various factors which can be include this threat, like competition, because the market is very high and there can be number of competitors, so competition will be higher. And there is also a political influence, and also some economic factors can be there, And also there are further pilot campaigns like people, timing, funding, and the major one is limited raw material like iron ore and many other. Steel industry. Steel industry played a major role in the global economy. Steel was extensively used in industries like construction, heavy engineering, infrastructure, developing shipping, automobiles, as well as the production of coal, natural gas, electricity, and raw minerals. The production of steel increased constantly over the years, and 1.5 billion tons of steel was produced in 2012 as against 0.85 million tons in the 2001. Steel, an alloy of iron and carbon, was one of the most recycled industrial material in the world, with 90% of the steel being reused, remanufactured, or recycled to create new products. In steelmaking, two fundamental rules were used: integrated steel plants and mini mills. This case is about hisarna. It is a new steel production technology that was developed as an alternative for the existing steel production technologies, which were energy intensive process and were high on carbon dioxide emissions. The new process came about in the wake of Paris Agreement, which devolved carbon dioxide emission globally. The European Union target to cut the emission to 80 to 80% of 1990 levels by 2050. The European Union was also looking at adapting circular economy, which would not reduce pressure on the environment but also enhance security of supply of raw material and lead to economic growth. As far as the steel industry was concerned, it was looking at increasing the efficiency of production and redesign production process to reduce carbon dioxide emissions. In this direction, in 2004, the steel industry in Europe formed a consortium law ultra low carbon dioxide steelmaking to identify technologies to help reduce carbon emissions, ensure energy efficiency, and achieve flexibility in the selection of raw material in the steel industry. The constraint was of the view that a completely new process needed to be developed as the limits of the existing production systems were already achieved. This led to a breakout technology, hisarna, which removed a number of energy-intensive processes, provide flexibility in terms of quality of raw material and use of fuels in the process of carbon dioxide emissions reduced by 20%, and by capturing the high quality carbon dioxide, the emission could be reduced by 80%. The emissions of other fine particles could be reduced. The technology was tested in pilot plant of Tata Steel Europe in the Netherlands, and the 75 billion million project was funded by ULCOS, European Union, and the Dutch government. Hisarna was a combination of two different technologies, one from metal and mining company Rio Tinto and other from Tata Steel. After years of trial and runs and experiments, Tata Steel was all set to take a new sustainable production process into an industry scale. This called for more investments, and it retained be the seems seen if the steel majors from across the world would show interest in adapting the new technology in a bid to reduce emissions or continue with the traditional steel making process. The main objectives of hisarna in this study is that to examine how steel industry could move toward a low carbon future and reduce the negative impact of its production, to examine and in the depth circular economy and role of steel, to understand the industry's approach towards sustainable development production, to demonstrate the way in which manufacturing process could be redesigned to increase production efficiency and achieve lower emissions. Process efficiency through hisarna. Hisarna was developed by Tata Steel in Izumiden, Netherlands. It was expected to allow production with at least 20% lower carbon dioxide emissions. The technology could significantly improve steel production. As a substitute to blast furnace process, Hisarna made the processing of iron ore and coal obsolete. In this process, the material were injected as powder and were converted into liquid iron. On further development to industrial scale, Sarna can reduce the carbon footprint by 20% with the use of carbon capture and strong technologies. The carbon footprint was expected to be 80% lower. CCF and SRV is a win-win combination of technologies. The heat to reduce and melt the iron ore was produced through oxygen. Sarna technology eliminated the process of converting iron ore into sinter or pellet and converting coking coal into coke. Hisarna could use raw material of low quality. The carbon monoxide that was formed in SLV was used to create hot gases that were used to provide heat for reacting occurring in CCF. It was 30% more energy efficient and 25% less carbon dioxide intensive. It could significantly improve steel production sustainability performance. It used nitrogen as carrier gas to dissolve carbon into hot metal. Its carbon collection was highly efficient. It could use biomass or natural gas instead of coal and reduce carbon dioxide emission. There is also a one point which name is circular economy. Circular economy products and the materials they contain are valued highly, unlike in the traditional linear economics model based on a take, make, consume, throw away pattern. In practice, a circular economy implies reduce waste to a minimum as well as reusing, repairing, refurbishing, and recycling existing materials and products that used to be considered as waste can be turned into a valuable sources. Moving toward a more circular economy could deliver benefits among which reduce pressure on the environment, enhance security of supply of raw materials, increase competitive innovation and growth and jobs. However, it would also face challenges among which finance, key economic enable, skills, consumer behavior, and also business models and multi-level governance. The circular economy refers to a move from linear business models in which products are manufactured from raw material used and then discarded to circular business model where products or parts are repaired, reused, returned and recycled. This concept is fundamental to the triple bottom line concept of sustainability, which focuses on the interplay between environment, social, and economic factors. The new smelting reduction process is SARNA. SARNA is a highly merging of cyclone converter furnace of Tata Steel and high smelt reduction vessel from Rio Tinto. SARNA, a new technology for producing steel, consisted for a reactor on the top which iron ore was injected. The ore is liquefied at higher temperature cyclone and dripped into the bottom of reactor. There coal was injected and the powder coal reacted with the molten ore to produce iron ore that was the base material used to produce high quality steel. Concentrated carbon dioxide was emitted from the reactor. The technology helped in removing several pre-processing steps and the quality of the raw material required was flexible compared to the traditional steel production systems. This resulted in several gains: reduction energy use, reduction of carbon dioxide emissions by 20%, decrease in the emission of fine particles like sulfur dioxide and nitrogen dioxide by 60 to 80. The CO2 that was emitted was highly concentrated. When steel industry was taken into considerations, it had advantages in the term of reduce, reuse, remanufacture, and recycle. The term recycle can be explained as steel can be recycled endlessly with no determinal effect on its properties. The magnetic properties in the steel allows it to be separated from the waste streams. Steel can be recycled ever since it was first made. All available steel scrap is recycled and over again to create new steel products in a closed material loop. Recycled steel maintains the inherent property of the original steel. These properties can be modified during the steel making process on through mechanical process to create the many thousands of advanced and commodity steel grades available. The quality of the steel production can also be improved on recycling.